Hi children, welcome to our video. 8th Standard Physics. This is Mrs. Manonmani P, MSc BO, Department of Physics. Yes children, today we are going to learn about chapter number 3, Force and Pressure. Already we have learned on last video about force, isn't it? Now we have to discuss about today's learning objectives such as introduction about pressure and applications. Now we have to learn about pressure. Here two boys are pushing the wooden box from one place to another. You know children, at the time only pressure will be produced when a force acts on an object. Force means a push or pull on an object. Here two boys are pushing the wooden box. At the time they are giving force. We will now describe how the effect of force applied by one object on another object depend on area of contact between the two objects. This will give us the definition of pressure. Here see children, two pictures are there. First one, now if we push hard on a piece of wood with our thumb, the thumb does not go into the wood, isn't it? But if we push a drawing pin into the wood with the same force of our thumb, the drawing pin goes into the wood. Why? What is the reason? Yes, our thumb does not go into the wood because the force of thumb is falling on a large area of the wood because the pressure on the wood is very small. But the drawing pin goes into the wood because due to the sharp tip of the drawing pin, the force of thumb is falling on a very small area of the wood, due to which then pressure on the wood becomes very large. So, from this we understood pressure is the force acting on a unit area of the object. The force of thumb produces small pressure which it acts on a large area. The larger the area of wood, at the time the pressure will be less. And then the area will be small, at the time the pressure will be greater. Now we have to learn about the definition of pressure. Pressure is the force acting on a unit area of the object. Formula for calculating pressure is force per unit area. Particular area, unit area, how much force will be there, that only we have to know about the pressure. Now we have to discuss about the unit of pressure. The SI unit of measuring force is Newton. Already you know children, the unit of force is Newton, and then SI unit of measuring area is square meter. So from this we have to understand the SI unit of measuring pressure is Newton per square meter, because that is a numerator, force will be there, area will be the denominator. So Newton per square meter, which is also called Pascal. Listen children, because of the greatest scientist Blaise Pascal, so only they have to give the unit name Pascal. So 1 Pascal equal to 1 Newton per square meter. 1 Pascal equal to 1 Newton per meter square. Like this also we have to say. Yes, Pascal is a very small unit of pressure, but we have to name a bigger unit of pressure called kilopascal. You know children, kilo means 1000. So the symbol of kilopascal is kPa. 1 kilopascal is equal to 1000 pascal. That is 1 kilopascal equal to 1000 pascal. So repeat after me, 1 kilopascal equal to 1000 pascal. Okay. Now we have to do numerical problem. Just listen the question now. A force of 100 Newton is applied to an object of area 2 meter square. Okay, the area, the object of an area 2 meter square, at the time the force 100 Newton we will apply. Now we have to find out the pressure, calculate the pressure. First I have to write the solution, and then force 100 Newton, area 2 meter square. Now we have to use the formula. Force means 100 Newton. You know, now say the formula, pressure equal to force per unit area. So 100 Newton by 2 meter square. Strike out this children. 1 2s are 2, 5 2s are 10. So 50. 50 Newton per meter square. Already I told before, 1 Pascal equal to Newton per meter square. So we have to write 50 Pascal. Thus the pressure is 50 Newton per square meter or 50 Pascals. So this is the answer for this question. Pressure equal to force per unit area. We have just studied, area is in the denominator of pressure formula. It means larger the area of surface, எந்த இடத்துல area of surface அதிகமாக இருக்கும் அங்கே pressure வந்து ஸ்மாலாக இருக்கும். Yes, area of surface smaller இருக்கும்போது the pressure will be very higher, but same force only we have to give in. Now we have to see, just wait. The area of the pointed end of a drawing pen is very small, due to which the force of thumb produces a large pressure on the piece of wood. This large pressure, now I am giving a large pressure. I have to use a hammer. Large pressure pushes the drawing pin into the piece of wood. From the above discussion, we have to conclude that pressure depends on two factors. One is force applied, another one area over which force act. Just to think, here two pictures are there. This fat man now just standing on the floor. At that time the pressure will be normal. Okay, but that man standing on the one leg, at that time the pressure will be very high. Yes. Now we have to see some examples about the applications of pressure. Have you seen this, children? A school bag. Yes. This children are wearing school bag. A school bag has a wide strap. This is a wide strap, children. That is made up of thick cloth, so that the weight of the bag may fall over a larger area of the shoulder of the child, producing less pressure on the shoulder. So only have to easily walk for wearing the school bag, and due to less pressure it is more comfortable to carry the heavy school bag. Children, school bag will be heavy, at the time less pressure only, due to the less pressure only it is comfortable for you. Now is time for example 2. Have you seen this man? Yes, this is a person employed to carry heavy luggage or other loads, is called a porter. Mostly railway stations we have to see this porters. Porters place a thick round piece of that cloth on their head when they carry heavy loads of passenger. By placing the thick round piece of cloth, that porter increase the area of contact. அவர் என்ன பண்ணுறாரு, அந்த காண்டாக்ட் அவருக்கும் அந்த ஏரியாவுக்கு நிறைய அந்த ஆப்ஜெக்ட்டுக்கும் உள்ள காண்டாக்டை அதிகப்படுத்துகிறாங்க. ஸோ அதனால த ப்ரெஷர் வில் பி லெஸ், அவங்களுக்கு ப்ரெஷர் குறையுது. ஸோ இட் பிகம்ஸ் ஈஸியர் டு கேரி த ஹெவி லோட். நவ் இட்ஸ் அ டைம் ஃபார் எக்ஸாம்பிள் 3. Children, your mother is using this sharp knife. Sharp knife has a very thin edge to its blade. So sharp knife cuts objects like vegetables better. Because what is the reason? Due to this thin edge, the force of her hand falls over a very small area of the object, producing a pressure, cuts the object easily. Because due to its very thin edge. Yes. Now it's the time for example 4. Children, have you seen this? Yes, sewing machine, sewing needle. The tip of a sewing needle is very sharp. So due to its sharp tip only, the needle may put the force on a very small area of the cloth. So at that time it produces a large pressure sufficient to pierce the cloth being stitched. Now it's a time for example 5. When a man stands on a cushion, then one day his 2 feet, you see this, children, 2 feet at the time are in contact with the cushion. Due to this, the weight of man falls on a small area of the cushion, producing a large pressure. So இப்போ பார்த்தீங்கன்னா அந்த children வந்து நிறைய ப்ரெஷர் கொடுத்து நிற்கிற மாதிரி இருக்கு, isn't it? So this large pressure causes a big depression in the cushion. On the other hand, when the same man is lying on the cushion, படுத்திருக்காங்க, then his whole body is in contact with the cushion. Now, in this case, the weight of man falls on a much larger area. The area will be larger. It produces small pressure. And the smaller pressure produces a very little depression in the cushion. Yes, from this we understood about the pressure. And then applications of pressure. Have you seen the children? Tractors. Yes, farmers used these tractors. The tractors have broad tires. These tires are very broad, so there is less pressure on the ground. So only tires do not sink into the comparatively soft ground in the field also. So this is also the application of pressure. And then children, have you seen this army tanks? Yes, here that white steel belt is provided over the wheels of army tank. So remaining wheels only they are giving pressure, more pressure, but that white steel belt is provided, that wheels of army tank, they exert less pressure on the ground, so only they do not sink into it. Now it's a time for example 8. Wooden sleepers. Have you seen the children? Yes, concrete sleepers are kept below the railway line. The railway line keele irukku pathiya, this is a wooden sleeper. So here also there is less pressure of the train on the ground. So only the railway line may not sink into the ground. Now it's a time for example 9. Here, have you seen this? Yes, this man is using snow shoes. Snow shoes have large flat soles, so that there is less pressure on the soft snow and stop the wearer from sinking into it. Adanala sink ahada, adala mulgada. Okay. Yes. Now it's a time for example 10. It is easier to walk on soft sand if we have flat shoes rather than the shoes with the small heels. Yes, flat shoe has a greater area in contact with the soft sand, so there is a less pressure on the sand. Because of this, the flat shoe only do not sink much in soft sand and it is easy to walk on it. But if it is if we wear a small heels, has a small area of contact with the soft sand, at the time it exerts a greater pressure on the soft sand. Due to this greater pressure, the small heels tend to sink deep into soft sand. அப்படியே கீழே வந்து அப்படியே dump ஆயிடும். So it making it difficult for the wearer to walk on soft sand. Yes children, I hope you understood this topic very well. I'll meet you on next video. Thank you.